Weight in artificial intelligence, a simplified explanation. In the context of artificial neural networks, weight is a numerical value assigned to each connection between neurons. It determines the strength and significance of the signal that passes from one neuron to another. Imagine a neural network as a complex network of interconnected nodes. Each node, or neuron, receives input signals, processes them, and produces an output signal. The weight associated with a connection between two neurons influences how much the input from the first neuron will impact the output of the second neuron. Here's a simplified example. Let's say we have a neural network trying to predict whether an email is spam or not. The input neurons might represent the presence or absence of certain words in the email. The output neuron would represent the prediction, spam or not spam. High weight. If a connection between the spam word neuron and the output neuron has a high weight, it means that the presence of the word spam strongly indicates that the email is likely spam. Low weight. If a connection between the hello word neuron and the output neuron has a low weight, it means that the presence of the word hello has little impact on whether the email is spam or not. The weights in a neural network are learned through a process called training. During training, the network is presented with many examples of input data and their corresponding correct outputs. The weights are adjusted iteratively to minimize the difference between the network's predicted outputs and the actual correct outputs. In essence, weights are the adjustable parameters that allow a neural network to learn and adapt to new data. By adjusting the weights, the network can fine-tune its ability to recognize patterns and make accurate predictions.